ahead and get started. We're going to do the first, I hope, hour 15 on OpenRefine, and then we'll spend more time on R just because it's a little bit of a higher ask. So the first thing that we have to do in every project after we gather data or find it on the internet is clean it. So there's some actual disagreement about what makes data messy. So I thought first we would just talk about what is messy data. So broadly defined, it's just data that's full of weird inconsistencies, either by the fault of a human, so we did something and made it look weird, or poorly designed systems like Excel. I have some examples of that. So these inconsistencies make it almost impossible to do any meaningful like searches, statistics, analysis, etc. So I was hoping that we could just briefly discuss what you all think is wrong with this table.
The pricing is not consistent.
But it's all $1,000. What do you mean?
Yeah. You're not going to be able to format that very well as a computer.
Mm-hmm.
Nor will you be able to format the dates.
Mm-hmm. I would say lack of a controlled vocabulary.
Library student, right? Okay, there you go. I love it. I love it so much.
Would somebody throw something at him, please?
What else is wrong with this?
It's all
just shout it out.
But not machine readable, so
yes.
a computer would not understand.
Exactly. We can look at this and conceptualize and say, this 2015-1014 is conceptually the same as this.
I would argue that I would never know that the 42291 is the October 14th.
Yeah, I think that's a star date. I don't even know where I got that from.
And then the bottom right, Idaho is not spelled correctly.
Yes, exactly. So besides even just the numerical inconsistencies, which make it hard for us to do stats, if I wanted to search for all of the sales from Idaho, I would have to know that I would have to search for the acronym, both with and without periods, US-ID, which is the abbreviation, Idaho lowercase, Idaho with a comma, and then misspelled Idaho. So it's actually possible for us to handle those as people, but when we're dealing with millions of rows, we want to scale that up. And we also sometimes, as people, for instance, using regular expressions or other patterns, we can get some of these, but not all. So if I was looking for all of the things that match ID, no matter where they are, I would get the first three rows, but I would never get the bottom three. So there are lots of ways that even the way we deal with messy data now is sort of inconsistent across finding all this messiness. So messy data has had a lot of problems in a lot of different domains. So I picked what I think are the two most famous. Has anyone heard of these? So the first one, gene name errors are introduced inadvertently when using Excel and bioinformatics. So the authors of this paper basically looked at, I think like 1,000. They did a pretty big study. They looked at papers in bioinformatics where people had included a data file. It's usually genomes. And they opened it up and they found that Excel was encoding the genomes as dates. There's like a big joke, Excel encodes everything as dates. But it's real, and they found it was irreversible, the condition, so they couldn't actually go back and find the original gene names. So that's a lot of work down the drain for a lot of people who did the right thing and shared their data, but unfortunately they used Excel and it's not good for anything.
The authors had saved it as an Excel file.
Yeah. So they basically said, here's my data. They were doing the good thing and sharing it, but it was a little bit messy, and so the original sort of analysis couldn't be reproduced, couldn't be recovered because of these things. And then there's this economics paper, which showed that countries with a debt over 90% of their GDP have a negative growth rate. It was published around the time Greece was having their major economic crisis, like 2008, 2009. So no one could actually reproduce the findings of this paper. So some grad students at UMass Amherst just emailed the authors saying, hey, can I have your data? And the authors were really nice. They said yes. So these are two examples of people doing the right thing and sharing, but being hindered by their choice of data format and messiness. So they got an Excel spreadsheet back, and it turned out there was a mistake in an Excel formula. So the thing that is bad about Excel, where was that? Or one of the things that are bad about spreadsheets in general is if you have a spreadsheet, and I have a formula that affects these rows, I'm never going to know unless I select these rows. The formulas are hidden from us as researchers, which is why I said data is read-only. So this is what happened to these researchers in economics. They used a built-in Excel formula to calculate GDP, and they left off 5 countries. I think it's like Australia, Austria, Denmark, Chile. I forget the 5th one. And so when those were factored in, the analysis came out completely different. It was a big retraction. It was a big deal because a lot of government policy was made off of this paper that came out at like the worst possible time to have an irreproducible paper. So I thought we could take a break here and just say, have you had similar experiences with these sorts of messy data, whether it's your data, somebody else's data? I think there's a hashtag on Twitter, which is hashtag someone else's data, which is just snarky people complaining about other people's data. But has this ever happened to you?
Just inadvertently, a student was working with a company that had set up 3 different environmental sensors. Obviously, the 3 environmental sensors had been set up by 3 different individuals, and so the logging names and the details of the data that was being logged was all unique, right? So you had, at least we were able to track it down, but it was, this was
took a long
a couple
time.
100,000 data points, right?
Right. Yikes. Do you have one, Tisha?
So there is a thing through the OSP office that you can download everyone who has applied for any kind of funding, and so when you download that table, it has like 300,000 rows. Unfortunately, it's formulated as a table, which you can't tell, and so it breaks the machine every time you try to open it because it's a huge table, even though all the fields aren't filled.
Huh.
So instead of just having a CSV that I can fix it, it doesn't fix it. So.
Yikes.
Yep.
Wow. Yeah.
It's not necessarily messy data per se, but in informatics all the time you've got programs that use different formats. So for example, if you've got chromosome 1 through 23 in humans, it will sometimes have CHR and the number, and sometimes it'll just have the number. And the algorithms don't know that CHR and the number is the same thing as just the number.
Right.
You've got to swap it back and forth using command line and stuff, which is a total pain in the rear.
Yeah, that's a lot to deal with. Is anybody else? Maybe? Yeah.
We use Qualtrics for survey data, and it doesn't.
The double headers.
Yeah.
It's
and
really
no
annoying.
yes aren't like 0 would be no or 1 would be yes.
Yeah.
Usually don't correlate.
Yeah, they forced you to use the Qualtrics reporting thing, which is not trustworthy. I actually use Qualtrics as well, and I looked at their crosstabs, and then I did crosstabs in R, and they were completely different. Yeah, I have beef with Qualtrics. Has anybody else?
Yeah, I do topic modeling on corpuses and have grad students enter metadata spreadsheets about the authors, and it's like, English document.
Of course.
These open refine, just facet those.
There you go. All right, so you're going to be my TA in this class then, if you're already using it for that purpose. So while we're on this topic, it seems like the key theme across everyone pretty much is spreadsheets. So what is wrong with spreadsheets? I mentioned one thing, which is you can't see when a formula has been applied to a spreadsheet. What else is wrong with spreadsheets? Because that's all we're going to be working with today, so it's a good thing to know.
Maybe spreadsheets as opposed to
Plain text, like tab separated file is tabular data, but it's not a spreadsheet.
CSV.
Yeah, sure.
Okay. With a spreadsheet, you never know if it's the original data because somebody could have done manipulations, changed the data, saved it
Yeah.
as.
There's no provenance. Is your problem? And you formatting?
Formatting, so the hidden characteristics of formatting.
Yeah, or even people encode different stuff in comments. So people have like weird column headers like SAM, and then they spell that out into a comment. But when I take an Excel spreadsheet on my Linux machine, I never see the comments. And also the colors are like completely backwards. So if people try to color code things, it's just a no-go. So this brings us to some of the best practices I want to talk about in regards to dealing with data and dealing with cleaning data. So I mentioned it the other day, or yesterday, that your raw data should be read-only to try and fix the problems of provenance. Does everyone know what provenance is?
Not really.
Okay. So, I am a researcher. I am on the web. Wow, the internet. I see a data point that I really like. I'm going to download it and see if I can use it for my analysis. So now it's on my computer. But it's super messy because nobody bothered to clean it. So I have to put it into OpenRefine, let's say, which is what I do. And that's really great. My data's all cleaned up, and I'm going to go analyze it. I'm going to use my R Markdown file. My R Markdown file is going to generate a PDF, which I'm going to submit to a journal. Provenance is this process. So the provenance of my final data comes from this place on the internet where I downloaded it. Now, you can have different types of provenance. So, for instance, the way I clean it in OpenRefine is an important workflow to know. It's important provenance. Does this make sense? So you can think of provenance just like your history. You're just tracking your history from getting the file to publishing your work. And this is really important for the issues. You never know if it's the original data or not. If you track this, you will not only know what the original data was, you'll have the original data, you'll have your processed results, you'll have your publication-ready plots, etc. So this brings us to today. And I will say provenance is extremely important for reproducibility as well. Can anyone think of why?
So I did this analysis and I got my results and I published it and I was like, yeah, I bet I can improve upon this. And so then I collected a bunch more data. And because I had kept all my code, I could just import the new data file, press the stata, just press the do file and literally run it through the same code with a larger sample size. And it basically does the whole thing again.
Great, exactly. Anybody else? When I try to go to verify somebody's claims, if I'm a reviewer on a paper and they said they did XYZ as their methodology, if they keep their provenance, then that's an easy check. Just go to that website. Hopefully it's still there if it's a trusted repository or something, some reliable source of the data. If I think there's something fussy about the way that they cleaned it, I can go back and look at their steps. And in fact, OpenRefine lets you automatically do that. So there's no easy conversion standard, which is what we talked about. So if I have the names Nicholas Wolf, all caps Nick Wolf, and Wolf, Nicholas, we could write a piece of software that ignores capitalization and punctuation, but it leaves out this other case if they exist in certain rows but not others. So all of this is very tedious, and this is where OpenRefine comes in. So OpenRefine has gone through a bunch of iterations. OpenRefine was formerly Google Refine, and before that it was Freebase GridWorks. It's always been open source actually, which is very cool. So it's an open source tool. It lets you load in data, clean it very quickly, and transform it, even geocode it. And we're going to be doing some geocoding today. We're going to make a map in R, so it's going to be very cool if we make it that far. So the main use of OpenRefine is data cleanup and transformation to other formats. So basically, we're going to track all of the actions on a data set, export it, store it. So everyone should have OpenRefine installed. So hopefully the installation was simple for you. You can import basically anything into OpenRefine, TSV, XML, JSON, Google Sheets. You can upload data from a URL. So if it lives somewhere else, you could just input the URL. OpenRefine will go out and get the data for you. You can also export it into a number of different formats, including Excel, if that's what you prefer to work in, TSV, CSV, even HTML tables, which is nice for the web. You can work with data sets that are about 100,000 rows. You can adjust the memory. You can install it on a server and give it more memories if you have a larger data set you'd like to clean. And they have really useful extensions, like for geocoding, for phylogenetic trees, and there's a bunch listed on their website. And the development community is very active. So typically, if there's a bug or if you want a feature, they're very quick to get it. Does all this make sense? I'm seeing very confused faces. Is it okay? Okay. Okay, so they have a bunch of tutorial videos and documentation at openrefine.org. They also have a very detailed wiki. I just want to pop out and show you the wiki because they have this great thing if you scroll down called recipes. At the very... And recipes essentially show you some basic things you'd like to do. So for instance, if this is in one cell, how do I separate 3 names into 3 different columns? And they show you some ways to do that. So they give you a lot of stock data cleaning code, for lack of a better word. It's not really code, that you can use in OpenRefine to get that. So the recipes page on the wiki is very, very good. Okay, so let's start it up. So in Windows, you just double-click the OpenRefine exe. My Linux dude, we have to navigate on the command line, and you got it? Okay. And everyone on Mac, it's just in the applications.
If you haven't opened it, you're going to need to go to the applications folder, right-click it, and select open, because the Apple will protect you. It's an unknown developer.
Okay. Did everybody hear that on Mac? Okay. Okay. Got it. Okay, so...
Maybe I can follow along on your document.
Your book, when I hit the page, does not show your newest version.
Yeah, the build failed, and I'm trying to fix it.
Sorry.
No, it's totally my beat. It's just because I need a different R image. Okay, but everyone should be loading OpenRefine with me. Everyone with me? Got OpenRefine open? Okay. So you can't close out this terminal. Just leave it running. It's the way OpenRefine needs to work. It makes a web server. Rest assured, everything is still local. Nothing is going to the web. This 127 is your home IP, so you don't have to worry about any security risks. It's all completely running locally. So
It didn't pull terminal.
It doesn't for Mac.
Okay, cool.
Okay, cool. All right, so let's create a project. It's the first thing that comes up. So when you browse, we should be able to find our data. So if you put it in your desktop, I put mine in a data folder. So here's my CSV. I just browsed for it. And when I click next, OpenRefine does a really nice job of previewing my data for me. For instance, I can change the character encoding if I know, for instance, the National Oceanic and Atmospheric Administration encodes their data really weirdly, so I can fix it to be consistent. Let me scroll to the...
How did you get that window?
If you hit
Okay,
encoding.
I just was looking down when you clicked.
It's this, if you just click into character encoding. But you don't have to do that.
You gotta scroll up and then, no, you gotta lift the whole box.
Mhm.
And then there's a cancel box.
You can decide to store blank cells as nulls or even store blank rows if that's useful for your data set. I might not want to store blank rows, which is a row that's completely blank in my data set. I don't care about that. If you care about it, go for it. You could discard the first line. You could just parse it as column headers. And then the last thing we're going to do before we create the project, because everything looks pretty good, is I'm going to change the project name. I'm going to name it something University Data. I'm just going to rename my project.
Should we be renaming ours?
Yes. Yes, rename your project along with me, because we are going to do best practices in file naming while we're here. Okay. So when we create the project, it's pretty quick for me, but it's 75,000 rows, so it might not be for others. Don't worry if it's not. I have to scroll over. So here's the initial parts of our data set. So now we can go and explore. So the best, the most useful thing to do first is this thing called faceting. So faceting is a really good way to see kind of the big picture of where the problems are in your data. So it's column-based. So you look at a particular column. You can do a text facet, which basically groups together all of the similar names in your column. So for instance, if I was to do a facet on university, I could sort by name. So École Polytechnique is at the front. I could sort it by count. So there's 8,000 rows for Pennsylvania State University. But you can see there's some weird inconsistencies. So there's all this weird stuff in our names. There, if I sort by name and scroll, there are some duplicates. We don't want duplicates. They mess up our data. So this is a facet. It's grouping like with like. Does that make sense? Okay. So you can also use facets to subset rows you want to change in bulk. So for instance, this Eccles Polytechnique has that weird, that's supposed to be for making accents, accent grave. I could click edit and just edit this right here and apply it to all the rows. I'm not going to because I'm going to show you a way to do it for all of the accents that come up there. So the facet information is always in the left panel. You can always exit out of it if you want. All the groups that have identical values will be grouped together. There are also some numeric plots, timeline if you have different dates. So you can facet together things with the same date. You can facet things by text length, which might be interesting for some folks, and even facet by blank. So you can see how many cells in this column are blank. So we're going to use a facet on the university column. So try sorting the university column by name and count. I already mentioned one problem with the data, but maybe you all can find some other problems with the data you could tell me about. What problems do you see in the university column? Anyone see any errors in this column?
Inconsistencies in capitalization.
Yep, inconsistencies in capitalization.
Initially, it looks like there's duplicates.
Yep, they're duplicates. Is everybody able to get to the facets? Is that everyone's there? Okay. Okay, so we see the facets. We've named some problems. Now we're going to fix things in bulk with this thing called Grell. So Grell is the Google Refine expression language. It's a way we can automate changes. You can think of it like a tiny scripting language. Usually it's like 10 characters gets you to where you need to go. It's not anything too much to do. So with Grell, you can query APIs, change data formats, split columns, and do a whole lot more as well. So you can use Grell in OpenRefine. You could also use Python. You could use Jython, which is basically Python designed to run on Java, or Clojure, which is a dialect of Lisp, which is a weird programming language. Okay, so we want to edit this column. So when we click into this list, there's literally just an edit column. And what I'm going to do is I'm going to add a column based on this column, because in case I mess up, I always at least have the original. So that brings us to this screen, and this screen lets us switch between those programming languages I mentioned. It gives us a help guide. So if we ever need to know a function, for instance, how many things are null, you can find out. And if you ever have a question, you can always just go through here. If there are particular expressions you use all the time, you can star them so you can easily come back. And they have a history. So actually, I get to reuse this, but I'll show you. So everyone should type this in, the value.unescape, and then in parentheses, in quotes, URL. And you can see OpenRefine before we make single quotes. So you can see the first immediate change. You can see this Lyon. So there is an accent, and now the accent is present. So basically what we just did is we used the function called unescape. And unescape, basically, we're saying for every value in this row, so for the whole, or column rather, so for the whole column, I want you to look for the weird things and fix them. And we used URL specifically because these are HTML. Does this make sense?
So there's a consistency to the weird things, and this just undoes it.
I've seen a few of these, so it's worth it to just go through, and because there might be other things I haven't seen. For instance, other like a umlaut or something that I haven't seen that might be useful. Okay. So when we hit OK,
I
You can tell by the, well, for instance, I only knew, to be honest, because in URL bars, whenever you have a space, it is %20. So I was like, this looks very similar to that, and I Googled it. So that was my personal process. I don't think there's a hard and fast way to tell. The unescape, you can have a few different arguments. So it doesn't just have to be URL. It could be JSON. It could be other things. So if there's a bunch of JSON in a column, you can filter on that as well. Does that make sense?
To enter this, or just
Yes, hit OK. I was just waiting. Oops, I forgot to enter a column name. Yeah, so I'm going to call it clean names. Clean uni names. So now when I look at the text facet for that, it looks pretty good. I don't see any of those things that we saw before. And I'm just going to delete the original column because I don't need it.
Okay.
And that's just edit column, remove this column. So now all I have are my nice clean university names and the rest. So is everyone able to get that far? Okay, great. Oh, okay, you're good? Okay. Okay.
Speed up and remove the column you didn't want to remove. Is it gone?
Nope. So there's this undo redo panel. Just go back to the step before.
Where was that?
It's next to facet and filter. It's undo and redo. You can click that and hit a. Oop.
But also your original CSV file is still sitting there, right? We've only read
Yes,
it.
yes, we've only read it, and that's a very good point, which is we can always redo things if we keep the data as read-only. Because right now the data that we see right now exists as an OpenRefine project. OpenRefine auto-saves this, which is nice, just in our downloads folder, I think is the default. And we can later export and look at it as well. You can export the project, and you can export a clean data set.
Is this HIPAA secure?
Yes, it's local. So as long as your laptop is HIPAA secure.
Okay. Oh, so it's
It's 100%
oh, but it's
local.
on your laptop. It's not on
Yeah.
the internet. Okay.
No, it's not on the internet. So it needs a web server, just like Jupyter Notebooks. So in Jupyter Notebooks, you also have to start a web server, but it's completely local. And so you could have somebody install this on like your lab server, which I assume is HIPAA compliant since you're in a hospital, and you can have it completely fine for you.
Did you open this specifically as read-only? Did you do something to?
Nope, that is just our personal choice. So when
How do
we
we know that choice has been made?
we make it. so it's a good point. So, oops, that's not what I wanted. Okay, so yesterday we talked about good file management. So one of the things we talked about was the folders. So we have one for a project. We have one called data, which has the original data. This is something we can read but not write to. You're not changing any of the data in this folder. If you want to change the data, put it in something called results. I'll call it analysis. Analyzed.
Is there an easy way on a Mac to set that folder or a file as read-only?
I don't know.
If you go into select the file,
Yep.
hit Command I.
Huh. Okay, so
Yep.
But the original
See.
file itself?
CMD plus I if you're on a Mac. I don't know, I've never tried it. But basically the,
It says down at the bottom, sharing permissions, open that up. And it tells you what it is. You can change that.
Great.
oh, there you go. So basically the idea is if we ever like massively screw up, we always have the original raw data to go back to. If we want to verify that what we did works, we can always go back to the original data. And it's a good practice to separate the steps out. And we had 2 other folders, but I'll leave them out for now. Okay. So great. So once all the names are cleaned up, we can find all those like weird nuanced spellings and semantic mistakes with clustering. So clustering basically finds groups that have like sort of different values that might potentially be alternative representations of the same thing. So it's going back to my all caps Nicholas Wolf, Wolf comma Nicholas, Nicholas Wolf example. So clustering is perhaps the most powerful thing that I use in OpenRefine besides the geocoding. And it's really good for cleaning mistyped. So if your student has English department, department English, you want to cluster to find those. And it has several clustering algorithms built in. So when you hit cluster, I don't know why my resolution is so weird. Oops, sorry. I can't scroll. Sorry, let me just change my resolution because I cannot. These algorithms, in the materials, which will be uploaded soon, there is a link. So let me scroll down. So for now, we can play around with the different clusters and see what we find. So in the first, we found 2 different groups. If we use key collision and the n-gram, we found another one. So this escaped detection the first time. So it's worth it to kind of play around and see what comes up. So I want to merge this because Montana State - Northern is the same whether there are spaces or not. So that's using key collision and the n-gram. The first one we used was key collision and fingerprint. If we go to the metaphone, we get a lot of noise. So sometimes this doesn't exactly work. So for instance, they thought all of these university of could potentially be the same thing, but we know they're not. So some clustering algorithms are going to be better than others. And the same with this one. So this one is sort of the same. University of Oregon, University of Regina. Are they really both the University of Oregon? No. Ithaca and Utica? No. I guess as long as they don't use that with Brigham Young in the U, it'll be okay.
University of Idaho, University of Utah.
Yeah, there you go. So it gets kind of weird, but it's good to just play around in each algorithm and see what you can find.
Is there a Seton Hill University as opposed to a Seton Hall?
I have no idea. So some things you just need a person.
When I was looking around at it, it said that there was like Wellesley College and Wellesley University. Are those different?
That is a Wesleyan.
Wellesley's different.
Well, there is a Wesley, I think.
Wesley's in Massachusetts.
Mm-hmm. But is there a university? Nope. So apparently there is no Wesley University. So if you see one...
Sorry, there's Wesleyan College and
Oh.
Wesleyan University?
Wesleyan.
Wesleyan College and Wesleyan University.
Huh, I actually don't know.
And there's only one Wesleyan College and 36 entries for Wesleyan University.
Yeah.
So it makes me think it might be the same.
Huh, isn't that interesting? So that's your choice as a researcher on whether or not you want to merge Wesleyan College with Wesleyan University. So I scrolled down. Can you see that on this? Okay. I scrolled on the text facet to where the 2 entries are. So I looked for Wesleyan College and Wesleyan University, just at the bottom. And I see that there's only 1 entry for Wesleyan College, but 36 for Wesleyan University. So there's a pretty high chance that they're the same thing. So in that case, I can just edit this right as is. And when I hit university, it will be, the row will be integrated. So now I have 37 things called Wesleyan University. That's a good catch. So is everyone with me up to this point? You clustered, you merged all your clusters. Okay, good. So has anyone ever used regular expressions? A few. They're really scary. I don't particularly like using them. There's a lot of times where I have to guess to make sure they're right. There's some websites where you can double check. So basically the way regular expressions work is you have a pattern of things. So everything is CHA underscore whatever, and that's a pattern. Say you have something that's CHA underscore, like some numbers, but you also have BHA. If you want to, and you might have BHAA. So you might have all these sort of different things in the data set. You could use a regular expression to say, hey, I want all of the rows that have 3 characters, then an underscore, and the first character has to be a B. So it's a way to do pattern matching. If there's lots of patterns in your data, you can use regular expressions to find them. And in OpenRefine, we can use that pattern recognition to correct weird data. Does this make sense? Promise? Okay. Because regular expressions are really not the funnest things in the world. And they look weird. So remember on the command line yesterday, I said you had to escape spaces? In OpenRefine, in regular expressions, you have to escape everything. Like, you have to escape the letter D because it's also stands for digits. So if you just have the digit. So it's even a bit trickier. You have to escape periods. You have to escape, a lot of stuff. So you may have noticed in the established column, where are you? There are lots of different types of dates. So there's one that has year, year, month, day. There's one that has just some text after it. There's ones that are just years. And this is inconsistent. It's not going to help me. I want to make a time plot of all the colleges that were founded on a certain year. And I can't do that if all of these are so inconsistent. So we're going to use a regular expression to fix this. So the first thing we have to look at is edit column, edit cells. And you click transform, and it brings us to the same sort of screen we saw before when we did add column based on this column.
Do we want to do that first, though? Do we want to create another column?
Sure, let's do it. Keeping me consistent, it's good. Okay, edit column, add column based on this column. And I put in some regular expressions. Can everyone read this regular expression? The contrast is not that great.
Yeah, contrast.
I don't know how to fix that.
Is that double quote?
Single quote. Wait, there are no quotes.
Yeah, there's stars.
They're asterisks. No, my bad. Is there a way I can fix it on the projector, or is it just my computer? Do you know?
Would it help if we turn the lights down, maybe?
Maybe.
Yeah.
Okay. Wait, I have a laser? Oh! Okay, this is a game changer. I'm laser pointing at everything, so enjoy. Okay, so... No, my...
Bigger would be better, but yeah.
Bigger?
I'm seeing, oh, there you go. Yeah.
I zoomed out because now I can't scroll down, but it's fine. Okay, so we're basically taking all the values, and we're looking for a column. Okay, I can't do that reasonably. Okay, so basically we're saying for all the values in this column, match. So this is the Google Refine function, match. Does everyone know what a function is? Okay, it's basically like a stored, that's a database term. It's basically like a preset script that you can call, that you can give information to, that will do your bidding.
Are those brackets around that zero?
Yes. Curly brackets.
Well,
Around the zero.
Oh, and those 0 square brackets. Okay, so basically what I'm saying is, forget everything before and after 4 digits. I just want that. I just want the year. So if we scroll down in the data, you'll notice that all of a sudden, I'm getting rid of university status because I just want the years. I don't care about anything else. I'm also getting rid of these weird, these just have hyphens as if they're not all still established to this day, which is not part of the data set. So we are basically clearing away all the rubble and just getting years. Do you want me to go over the expression?
Oh, yeah, that's
Well-
what I was going to ask. Because for those, it looks like just getting the first 4 characters of the string. But for 26 and 27, at least for me, the data points, it says established in 1985. So how is it just getting 1985? If you scroll down.
It only goes to 25 on the preview. But here, I'll hit.
Yeah, mine too.
Yours too?
It's because the regular expression she said, she let it know, I don't care what comes before 4 digits or what comes after 4 digits. I just want every instance of 4 digits in a row.
So if there was a word that was 4 digits, or 4 characters, or is it?
No, it's the D refers to digits specifically.
Okay.
Yeah.
Value match.
No, that you would have to do differently. Okay, so I'm going to hit OK. I'm just going to call it 4 digits.
Can I just ask a workflow question?
Yeah.
So I see where if we went to the undo, redo, if we wanted to go back later and annotate what we had done to clean the data, we would see the things we had actually done, but at what point in your workflow would you stop and say, this is why I'm making the decision to get rid of some of the text, and this is why I'm getting rid of?
Yeah, it's a good question. I typically have a data readme. So for like if this is a clean data set, so I would give kind of an overview of how I cleaned it. And actually you can export this into something machine readable. So I could basically give somebody this for them to rerun on their own. So in my data readme, which is just a little bit of extra documentation, I would say, here was the data. I made these choices. I said Wesleyan College and Wesleyan were the same thing for this reason. And here's my entire workflow for you to import it to OpenRefine to work on. So not everyone does a data readme. Some people just include it in the larger readme file of the repository of the project. So it's a personal choice, but I prefer to do it like that for that reason.
Is there any advantages within OpenRefine compared to just working in R? Where when I'm working in R, all of my changes are going to be part of my code. Right. It's going to be part of my.
In what?
You could document it in your code.
I can document it in the code.
Well, we're going to see that in our R lesson.
Right now, I mean, I have a set of greps, or this language I have to learn, where I've already got a set of language I already know.
Sure.
But is there anything that you would say is no? This makes this worth the effort.
It's a ramp up. So if you have somebody who is not familiar with R in the way that you are, because you work with it, sounds like quite a bit. But for like a lot of people who get data from others who only know a very specific set of scripts or might have been given a script from their PI, it's useful to have something that's visual that still has the power of using something like R. So I can still, the stuff we've been using are less than 25 characters, so it's not a big step up in terms of like learning how to do, for instance, a regular expression or something. So I would say it's a ramp to those things rather than I use this, then this, then this. I also use OpenRefine for things I wouldn't use, such as geocoding. So I geocode in OpenRefine because in the Grell language, I can just directly query the Google Maps API with, again, like a sentence-long command, which is way less than I would do it in Python or in R.
I think it's very long in R, but we'll take it.
All right, well, we'll take bets, but it's a good ramp up, I would say, is the main reason. Yeah.
Fair enough.
It's easier than the command line for sure. Okay, where were we? All right, we made this new column called 4 digits. And you said row 26 for you was weird looking?
Yes. Well, it wasn't weird looking. I was just wondering how it specifically picked out the numbers.
Oh,
you're just pulling the first 4 characters
right.
of the string.
Because right now, when I just went through all of the things that had 4 digits, I don't see any extra text like you were seeing.
He meant on the previous.
Oh, in the what?
I was confused about what.
Oh, I see. You didn't the regular expression itself.
Yeah.
Okay. Well, all right. We'll switch gears. So.
The 4-digit column you just made, text should theoretically be gone.
Yeah. So if you use this, everything is gone except the 4 digits.
And if it's not,
You probably entered the regular expression in wrong.
Do you want me to put it in a text file and put it
gives
bigger?
you a little preview that you can check.
Yeah. Okay. So, one thing we didn't talk about with Excel and spreadsheets in general, well, we talked about a little, is that it encodes things weirdly. So like the joke, everything is a date to Excel. This makes analysis hard. So we can set very strict data types in OpenRefine, which are useful when we carry stuff out of here into the R lesson, for instance. So what data type does everybody think established is? Our old column. Or actually, what does everyone think our new column, 4 digits, is?
Integer.
Incorrect. Any other guesses? Yeah, it's a string. So, but actually, should we delete the established column? Okay. There's some strong feelings. Okay, I'm going to rename 4 digits to established then. Because it's... Okay. Everyone with me? Okay. What's the... Was it the regular expression?
I gotta remember how to get back to the regular expression now.
So if you go to cells, the
Cells.
yeah, transform, then you type in the regular expression there.
Which I can't see.
I'll go back to that page. Okay, you doing good? Okay, everybody here, you okay? You two are doing okay?
Yep.
Okay, great. All right, let me go back to the.
I mean, right now I can do like a group by and summarize by universities, and I can see.
Value.match, parentheses, / period, asterisks, parenthesis, backdash, D, curly brackets, 4, end parenthesis, period, asterisk, / end parentheses, 0 in square brackets. Okay. Okay. So, we are going to change a data type, which is not extremely hard in OpenRefine. So in our established, it is just edit cells, common transformations to date. Or to number if you'd rather have it be an integer. What do you think, integer or date?
Date.
Date, okay. Oh, our numbers are gone. Our 4 digits are gone. So OpenRefine has decided that all of the dates have to have, if you can't read, it says 0101.
Undo.
So should we split it into different columns or undo? Split year, month, day into different columns or undo? Actually, it's 2 clicks. So if you go to edit column, it's split into several columns.
But you didn't have the month inherent in the data to begin with, so you're making it up.
They just put the 1st of January.
Right, so why, I mean, that's made up data.
We should just
Yeah.
convert it to an integer column, because we're not adding any unknown data.
Right.
Huh. Oops, I'm going to undo that.
Text transformations. I clicked on this here.
Wait, I'm confused.
I'm going back to rename it. So in my undo redo, I have 2 other things that I did, which was transform it all to dates or not. So I just went back to when I renamed it because I don't want to transform it again. So you just click it.
Now it's like, this is where I'm at. This is where I was. Now it's back.
Now we can do a common transformation to number.
So do I need to apply that when I selected my old spot?
Nope, you can just keep on trucking.
Okay.
So now you can tell that this data type is a number because it is green. So everything that is not green is a string. You can switch to other things such as, look at this number doctoral.
What type of number is it?
Maybe we'll see an R. I think it's a double. No, just kidding, it's an integer. So you can trim trailing and leading white space. So if there's lots of extra white space in your cells for whatever reason, if there's consecutive white space, like if we look at this, for instance, I don't know why this cell is so big compared to other things. It looks like there's some weird white space issues.
There's a double line up there on the
Oh, okay. Okay. Well, it could be an extra white space. So it's a good way to just keep that in check. Great. So regular expressions are not the only way we can transform data in a cell. We can also use 2 functions called replace and contains to normalize the data. So in our endowment column, there are a lot of stray values. What do you see are a few that we need to look out for?
Applicable and Not applicable.
Not applicable. There are no endowments at Montserrat. Oh, that's sad. That's like next to my hometown.
Where do you live?
I grew up in Hamilton, Massachusetts. That's in Beverly, Massachusetts. If you're not seeing anything, you can also sort. You can sort the column. So if you go to endowment and click sort, you can search A through Z, Z through A. I might search Z through A. Looks like there's a weird flag in this. And it's billion. So somebody decided to add the word billion instead of just writing out the number. So that's one thing to look out for, right? It's not a number. It's partly numbers and partly text.
Could it be a symbol for whatever the Philippine currency is that we don't know?
It looks like P. It looks like a P. It looks like Unicode.
Like dollar signs.
Yep, exactly. All right, I'm going to write this down. So problems with this thing. Weird money symbols. Letters and numbers mixed together, which are not good, generally. NA. We could decide we want something different than NA, such as 0. Because I've seen 0 in other columns, and I'm not completely sure why it's not in this one, for instance. There's also, such as P, dollar signs.
Oh my gosh, some of them just say US dash dash billion.
Okay, US dash dash billion.
That's not I mean, how many?
Well, there you go.
US dollar sign dash dash.
There's also, sometimes I just saw USD randomly inserted into places instead of the dollar sign. In other places, there's just a dash. So this particular column is super messy. And before we put it into R to do our analysis, we should probably fix it. So in that column, let's do our thing, add a column based on this column. We can call it no USD. And I'm going to use the following expressions. Yep. Yeah, I'm sorry. So it's value.replace. Here, I'll zoom in. Is that better? I don't know why the contrast got better. Okay.
Sorry, is it value replace, comma replace, or dot replace?
Dot replace. So whenever it's a function, after something like value or call or row, it's always a dot in OpenRefine.
Is there any difference between the second and third row? You have value dot replace US dot or US space dollar sign.
Yes.
And then
So one has a space, one doesn't. The space counts.
But going from row 2 to 3, you have the same replace
I
command.
feel like, can we copy and paste and then add the third replace?
You can do that.
So the second
We
one,
can.
Can you explain the value replace dot replace? I mean that's one command, right?
It's a function, so it's basically saying find all the instances of USD in this column and replace them with a blank. So get rid of them.
And what's the next one?
Sorry?
The next one.
The next one is find all of the values that have this space and replace them with, oh, you're right.
Well, then what's the?
Yeah, you're right.
Dot
That
replace.
was a bad paste job. Good catch. Yeah.
I'm super confused. how could you do value dot replace something dot replace something dot replace something?
Because you can chain the replace.
Okay.
Okay, that's
You can just
fine.
chain
I
it.
just don't know what that means.
It means you can, like if I didn't do that, then we would have to
You could write each line as another value replace, value
Okay.
replace, value replace.
Mhm.
You
That
just-
makes more sense to me.
Okay, well if this visually makes sense for people, just know you can chain them. Okay.
What about the funky looking one for foreign currency?
That is something we have to deal with because if we're getting rid of USD, that implies that our column is going to be in USD. So if it's in a Filipino currency, that's not USD. So we have to do some special sauce to put that into USD. Does that make sense?
Yes, but we're gonna leave it for now, and we're gonna do that in whatever we're gonna do.
There's also just US. Okay, value.replace. Okay, I'm going to zoom out. Call it new US signs. So now when I look here, there's still, oh, there's a B too. I don't know what the B is. Is that a pound?
That's foreign currency.
Pound? I don't know what that is. Zoom out again.
Give some foreign place or not.
Or can universities get foreign endowments?
That was looked to be.
Because these,
I'm
yeah.
guessing it's a foreign university.
Okay.
Therefore, it's foreign currency. So we shouldn't be replacing that right now, right?
So then, would you all rather have something that has a dollar sign? Do we want to leave off this last replace since everything else has the sign of their country?
Yeah.
Okay. So the point was made that in this list there are foreign universities.
Yeah.
So right now we're getting rid of all the signs of the US, but the signs of the foreign currency would still be there. So do we leave this?
Well, we have to add.
No.
This is discussion. Yeah, what do you want to do?
I mean, if you want
You
to,
should leave it because that changes.
it would be better to put the unit of the currency in another column. So
Yeah.
you could define the number and then define the currency itself separate.
Or just
I
accept
think you
the
should put
number
them
not
all in the
equal
same
to the
currency so we can compare them and stuff. Because if you're like.
That's a choice from the research. That's a research question, right? Do we compare it all in the same currency? Is that something we're interested in investigating?
It
I think
depends
it's
on
gonna
what
be
sort of
meaningless.
data analysis we're
Yeah.
doing on it. Because if we're trying to find, like, percentage of GDP goes to universities per country, like you might want to have that in the value of, or like the unit of whatever money system that country uses. Or if you can only get GDP in dollars, you obviously want that value in dollars.
Yeah.
But to do math with the number, it's gonna have to be an integer, so
Yeah,
we'll have to
I-
make
You
it
would
an
have to,
integer
you
at
would
some
have to have
point.
the exchange rate and do all of that.
We can store it with a dollar sign if it's easier, but. because
If we
like-
store with a dollar sign, we can also split, as long as it's the first character, we can split the first character
Or just drop it.
and put it into a separate column and then
You
say,
can't just automatically restore it with a US dollar sign because then you have to do the conversion for how much it actually costs in US dollars.
so the idea is that we would have one column that is just currency, or price rather, or endowment. And then the column right next to it would be the currency type. So USD, I don't know what the P is. What's the sign for a pound? One of those. Pounds, etc. So the idea is that each of these, so the idea is here, these would all be integers. And they would be associated with the currency, so you still have that.
Then why not
Is that what we
just-
wanna do?
But then why not just leave the sign next to the amount? You're not doing anything other than.
So I can't do math then. So if I wanted to like add another column of exchange rates, then I could immediately go the currency, the exchange rate, and then I can make a new column called US dollars.
And then-
So I can do the math just right off the bat.
So the idea is,
There makes math impossible.
Because it has to sort of a string, not a.
I mean, you can do that conversion at the point of calculation.
Yeah, I was gonna say, but that's considering we actually add the conversion in on this day. But if we're not going to add the conversion.
We're not gonna do that
there's
right
no
now.
point in separating
But I think this is a really good discussion because, one, it shows how important data cleaning is to your methodology, which is something I think a lot of us take for granted. Certainly I do.
So the other thing is if I'm going to do anything with the data, I'm probably going to be graphing it, and it's not graphable if it's in something other than a number. And if I have everything in the currency, I can also filter by that currency, so I can say easily filter just by everything that's in a row with US dollars and only work with things that are in US dollars. I just see a lot of advantages to pulling it out.
Sure. However, there are also, like, for the human readable sake, for your sake, if you have endowments as a data point you don't plan to use, it might not be worth your mental energy to separate it into 5 different columns.
That's what I'm saying.
Yeah, exactly. And so these are all,
for the purpose of this class.
I mean, we're not going to
We
do
can
the
learn
5
it
columns in
anyway,
this class.
We're not going to have to separate it all into
Yeah.
how many columns.
So the idea, yeah,
I have a different question.
sure.
It seems like it's changing it, but the dollar sign is still there.
On glass.
Even though you value or place dollar sign with nothing. Because in your task column about what it looked like, there's still a dollar sign there.
Yeah, I see that.
And mine too, on my computer.
Yeah. Huh.
Assuming the value.
There's 2 slashes?
How do I type
Oh, no. Okay. Did everybody hear this weird thing that just happened? Okay. This is a good case for keeping the dollar sign in for right now. So this has 2 slashes through it, and the one on my computer has 1 through it. So even though this is correct, it's still not filtering because I don't have the 2 slashes. So all this to say that data cleaning in general is in and of itself a messy process. It takes a lot of forethought. So like you're thinking, I want to graph this later on. I'm going to do this right now. You're thinking, I'm going to leave it alone right now. Maybe I'll come back to it if I have time, if I really need the value.
Just to agree with you on something, if you were going to do a graphic, if you were going to put this into a table, using even in R, where you create tables, having in leaving the dollar sign in there would be extremely useful.
Exactly. So our choices, even at this like super granular level, matter a lot. For reproducibility's sake, it matters. Whether or not if I'm trying to reproduce a table, it doesn't really matter if I have the dollar sign. If I'm trying to reproduce a graph, it matters if I have the dollar sign. It matters what analysis you're trying to do. And so all of these things are possible in OpenRefine. I can make those 5 columns now. I could leave the dollar sign in now. Yeah. No, all really good points. And I think the fact that there's so much varying level of opinion really speaks to the importance of sort of ironing all this out before you start really thinking about your analysis down the road. Some people, like a lot of people, do data cleaning on the fly. Like, I need this now, so I'm going to clean it now. I don't need this now, I'm not going to clean it now. But even thinking about how you're going to represent the data later on, it's important to keep that in mind as you're cleaning.
I also found if you have the dot replace instead of value dot replace, it'll actually, I don't know if it can do multiple expressions in one.
You can chain them.
Right. And I chained all mine and it tended to work, so it took out the dollar signs. I don't know if that.
Oh.
See like that.
There you go.
Why would that happen?
So we have now a column that says no US signs. We kept in all the stuff from everyone else. If we wanted to add a column that just takes the first symbol and puts it into a new column, that's very simple, to split the column on the first character. So if you wanted to keep the currency information, that's something we could do. We're going to move on from that though, but it was a really good discussion. So here's another thing which we can do. So the endowment column is obviously far from being well normalized. And does everyone know what I mean when I say normalized? Like all in one type? Yeah. So the one thing that was annoying me were like the billions and the millions. So I want to put those into actual numbers. So for instance, every time it says million, I'm going to do math and actually make it a million. Does that make sense? Is that something folks would want to do? Is there any argument against? Okay, good. Well, not good. I would be happy to see other arguments. Okay. So in OpenRefine, I'm going to do it in our no US signs, which is the new column we made. I'm just going to edit the cells if we can go back to it if we need to. Okay. Huh. Where is the, all right, I can't preview the, I'll switch to billions. Billions.
What? Oh.
Ruh-roh, cannot parse to number. Why can't it parse to number? Because there's a billion. Damn. This is not supposed to return a Boolean.
Is that an asterisk after the second parentheses before the?
Yeah, it's for math, so we're just timesing it. But I don't know why this is returning a Boolean. Huh.
I'm getting null.
Yeah, no, it's well, you should be getting true or false apparently.
I'm getting null.
Did I just?
Is it because you're converting it to 0 before you're multiplying it? You're converting it to null. You're going from billion to blank, and then multiplying blank times a billion.
What changed between now and last week that this
Is it
breaks?
supposed to say true and false on the column?
No, it's supposed to translate into the number.
Now put in two number.
That's weird.
Why is yours wrapping?
What? Why is mine wrapping?
And why did it drop down when you pasted it?
I did a new line. You're saying not to do. It doesn't matter if I do a new line or not.
So I did it without a space between the parentheses and two number, and mine's coming up with false and true.
Yeah. No, it's supposed to be a number. Because you're basically saying replace the million with nothing and then multiply what you got times 1,000
Why?
or a billion.
You've got it mixed first. You've got saying billion, and then you're multiplying by a million, which isn't good.
Well, whoops.
No, the first one says billion.
And then you need to add 3 more zeros to that number. And then we need a separate one for million, right?
Yeah, but. Huh.
So the value contains billion. See, is that just like trying to identify what column or what rows contain it? Isn't that included in the value replace? Won't it automatically find anything?
You mean just do that?
Yeah.
Which says cannot parse to a number. Okay, team, we're gonna have to come back to this one. 'Cause I don't know why it is broken right now. Or why my thing is broken. Sorry about that. We'll switch to geocoding and then we'll take a break. And then we'll come back for R. Does that sound okay?
Yep.
I'll try and fix this in the break. Okay. So we can do a lot more with open refine than cleaning, although cleaning is by far its main purpose and most powerful function. So we can actually query Google Maps. So it's better if only I do it because I will get rate limited. So everyone just let me do it. And you can watch mine. Okay. So we have a column called country. And what I can do is add a column by fetching URLs. So what I'm going to do is I am going to, are you serious right now? Oops, did I not copy the full thing? Oh, come on. This should be working. I don't know why. I did it this morning, too. Geocoding. Well, if all else fails, you can follow the instructions from the geocoding, which is, oh, I forgot the quotes. All right, quotes are important. There we go. Okay, thank you, computer. Okay, I forgot the quotes on the URL. So when you do this on a URL, use the quotes. So basically what I'm doing is I'm taking the word Philippines and all of the values of each of the rows, and I am sending it to Google Maps API, and I'm going to get back a bunch of JSON, which gives me the latitude and longitude. So when I do this, OpenRefine has created a column for me by fetching this expression. So basically, this is just the Google Maps query. I'm just straight up querying it and just giving it the URL. So this is, yeah, we'll see. Usually it goes to 0 and then immediately goes to like 99.
No,
so
this is like life-changing.
Oh, okay. Well, that's good.
If this works.
It works. I know it works because it's on their thing. So I got this from the wiki, actually, and I've been using it ever since. And I can show you an example of something I made it with. So I made this little list of women who do work towards like open science, open code, open data. Because there was like a whole thread on Twitter like, oh, there are no women who do this. I'm like, actually, there are thousands of us. So I made a list. And I got their affiliations, their Twitters, etc. And I use OpenRefine to geocode to make a map so that if you're having a conference, oh, that's too far out. If you're having a conference on openness, you care about gender parity, then you can find some folks on the map and maybe ask them to speak on a panel. So this is one real world thing where all I had is somebody's affiliation, just their institution. I was able to use OpenRefine to geocode based on their institution, because people's home address is creepy. And then I was able just to plug exactly what I got into a map. And we're going to be doing that in the R lesson as soon as this finishes running, which hopefully will be soon. Does anyone have any questions while this is running?
I think I might have figured out what the issue was. At least for me, it returns null. Like the issue with converting billions to numbers, it returns null because we might have that special character of whatever that unit of money is in the column. So if we could split it up,
You should be able to change it.
then we could just do the conversion to digits.
Yeah, so
the value column.
if everybody goes to edit column, I'm going to look on with you. Oh, you're good. Hit cancel. You're going to kill my rate limit. You can do it later. Okay. So in the column, if you go to split into several, edit columns, split into several columns, you can say split by separator or split by field lengths. So that's just a character. So this is the first character. So you would select that and just put in 1. And it gets the first character. It should get the first character. Does it get endowment?
This is the one you didn't do all the USD stuff
Yeah, because it has that. We want that first character. So split into several. By field length, hit 1. Should be the first one.
The digit 1 in that field length?
The digit 1.
I feel like no, I only have the.
Yeah, we
I don't
only
have the
where
number
did
that
the-
follows it.
Because not all of them have it.
Is that supposed to be under endowment?
Yes.
Split on anything that's not.
Yeah.
Yeah. Redo.
I mean,
Okay.
I think this is a good point. I mean, just data sets, especially for messy data sets, half the 90% of the work can be cleaning the data sets where you can actually
Yes,
something with
for
it.
sure.
Well, it's because after splitting, you have to remove this column check. That's not.
Okay, I'm gonna hit cancel on Google because it's taking forever. But you can follow along on the OpenRefine geocoding. So it's just on their wiki. It's the thing called geocoding. So if that's something that would be useful for you, great. So the last little step is I told you that you could send your process to somebody else, and using OpenRefine, they can follow the same steps. So that is in our little undo and redo. So basically, OpenRefine saves every single change you make to a document in a JSON file. So you don't really have to know what JSON is. It's machine and human readable. And basically, you could give it to somebody else, and regardless of what operating system they're on, whatever, if they have your data set and they have this JSON script, they can follow your exact data cleaning steps. So if we go to undo and redo, and we hit extract, you'll notice we can check and uncheck different steps. So for instance, this looks to be repeated 3 times. Maybe we don't need that 3 times. I'm just going to send it all for the sake of transparency. So basically all you have to do is copy this, open up your favorite text editor, and save it. I would call it unidatacleaning.json. And then I could send that to somebody else, and they could use it. They could import that into OpenRefine by using the apply. So they could take all that JSON I just copied, put it in here, and have the same steps. So you can very easily reproduce somebody else's analysis without having to install a bunch of extra packages, make sure your operating systems are the same, make sure your version of XYZ is the same. As long as they can get to here, they can follow your exact steps. So it's a very powerful tool for reproducibly and cross-platform data cleaning reproducibility. Okay, so let's, do you guys need me to go over saving and exporting? It was the last step. Basically, there's 2 ways you can do it. You can export the whole project, which gives you basically a zip folder. And in that zip folder, you have all of that JSON, all of your history. So you have a change log. You can also export the data in a number of ways. I would recommend you export the project and the clean data set, because it's easier just to have the clean data set. And then congrats, you have reproducibly cleaned your data set with OpenRefine. Okay, so let's take 10 minutes. We'll relax, then we'll come back, do R and RStudio.
So then if I wanted to do another project without doing anything, like say, okay, I'm not ready to export my project or export my data, I can just go over here to OpenRefine and start a new project?
Mm-hmm.
Okay.
So if you click the OpenRefine logo,
Yep.
and open project, you can see I have 2 projects. I have the project I did that actually works. I don't know why this one doesn't work. But you can see like I geocoded it. The endowments are correct. And I use the same exact things I put in our book, so I don't know what I did wrong between now and then. Exactly. So I'm going to give everyone the clean data set, but in 10 minutes. R&R Studio, there are a few people in here who have used R&R Studio. But for those of you who this is your first foray, we're taking it slow, so don't worry. So R is a programming language, and RStudio is what's called an IDE, so it's a development environment for R. You can use RStudio to write R scripts, to build websites, to write R packages. So it's a pretty well-developed interactive interface for working with R. So does anyone know the history of R? It's actually really funny. All right, so there used to be this thing called S, which was a proprietary language, and a bunch of statisticians got pissed that it wasn't open source.
S for statistics.
And then they implemented R, which, so they were just being kind of snarky, which is always hilarious to me. So basically, If we have R without RStudio, we would have to write our text in a text editor and then run it on the command line, but we don't want to do that. So we're going to use RStudio, and in RStudio we'll be able to navigate different files in our computer, inspect different variables, look at plots. So there's a lot you can do with it. So why learn R? So R, as opposed to some other statistical packages, has advantages. So for one, there's not any pointing and clicking. Can anyone tell me why pointing and clicking is bad for reproducibility? Yes.
And it's slow as hell.
And it is slow as hell, which is not super about reproducibility, but definitely a bad thing. So the idea is, unless someone is standing over your shoulder capturing everything you click, there's a very good chance of human error. You say, oh, you have to click this first. Oh, I forgot about that. You have to click that first, so on and so forth. With R and in scripts in general, that is all avoided. So you can just simply give somebody an R script. Hopefully, it will be working for them. So also, it makes your analysis a lot more clear. So if you are doing topic modeling, there's lots of good stuff in R for topic modeling. Instead, you can give that code to someone else. They can inspect it. It's good for peer review in that way. And R integrates with other tools. R integrates with other tools that are really, really useful to generate manuscripts from code. So for instance, I generate a lot of my LaTeX from R because I hate writing LaTeX. And so I actually end up writing a lot of my academic papers using R Markdown.
What?
Yeah. I can show you. It's beautiful. And they always look great. And in fact, R has a lot of different templates. They have like an Elsevier template, a Wiley template, Copernicus, ACM, Journal of Open Source Software. So they have all these different templates for you to create like executable papers, which is what I like to call them. So the good thing about that too is the good thing about using R Markdown, which is .R capital MD, is you have all this text, and then you have chunks of code, and the chunks of code can vary between languages. So you can have R, SQL, Python all in the same executable paper. If your data changes, you don't have to regenerate anything, you just run the code again. So you don't have to like futz around making your visualizations, you can just run it. So it makes it a lot easier on you. It's just an efficient way to do things, so I think. It has really wide adoption. It has about 10,000 different packages that can be installed beyond its kind of stock statistics. It has packages for image analysis, qualitative data analysis, GIS, population genetics. There's just a lot out there. And the skills you learn with R scale. So you can install R on any server, on any computer. And if your data set has hundreds of lines or hundreds of millions of lines, it really doesn't matter. It will scale with you. So these are some of the reasons why people like R. Do you want to say why you like R? I know you use it.
All the above.
Okay. All right, so we're going to create a project in RStudio, and then we're going to write some Markdown files. And so basically, a project is a .rproj extension. It's basically a self-contained little space for you to keep track of all of your work. Excuse me. It creates a hidden directory like Git. Don't mess with it. Where it keeps project-specific temporary files, so like it auto-saves your stuff. And if you don't have a project, I don't think it does that. RStudio doesn't auto-save your stuff. And so then you can send someone a project file, and it will auto-load your R space for somebody else as well. So it's a good way to move things around. Okay. This guy tweeted, and I liked it. He said, managing your projects in a reproducible fashion doesn't just make your work reproducible, it makes your life easier. And that's kind of the goal. Do you know him?
No, I don't know. I was going to say the other thing that you have an option of is they're called notebooks.
Yeah.
They're basically markdown language, but it actually will, if you can view it either as an HTML or you can view it as a document, and it's executable. So as long as, but it doesn't, you have to say it's in the data set. If the person drops the data in the same file structure, it should run.
Yep. That's a very good point as well. Notebooks. Okay, so did everyone keep their Git project folders on their computers from yesterday? All right, that'll make things easier. So let's open up RStudio. Hopefully mine didn't totally break when I just killed it. And we're going to create a new project. So it's just File, New Project. You're going to click Existing Directory, and you're going to point it towards your Git project folder. So wherever that is for you. So it should be something like Utah project, I think is what everyone named theirs yesterday. All right.
Where we put the files where that's going, right?
Yep. So then you create project, and then you will get into OpenRefine. RStudio, pardon me. So this is what RStudio looks like for me. This is my RStudio project, or this is my project to build the book for class. So you can see there's 4 different things. There's both the R console and the terminal. So we were on the terminal yesterday for Git. So you can access the terminal from here. And you can access the R console from here, which chances are you won't need all that much, but it's nice to have. You have your files, so you can view all the packages you have installed. So like ggplot2, that's something I need for visualizations. I better check in my packages that it's there. It has viewers for when you make plots, and as well as the plots that you can export into lots of different formats. And the environment, you should have nothing there. I just reran my stuff. But you should also see Git. Does everyone see Git? Okay, so I had you drop it into our folder from yesterday, specifically for the reason that we can interface with Git right from RStudio, which is very helpful. And it's a cool way to visualize the environment. So that's what we're going to do next time. Or we're going to do that at the end, should we have time. Okay, so one of the advantages of RStudio, everything is right there. You have your environment, you have Git, you have your source code to where you can write, and you have a list of all your files. So this is really nice. It's a one-stop shop. So now we are going to go over a few different packages. We're not going to use them, but I just thought you should be aware of them. So we talked a lot about this project structure. There are actually multiple R packages that generate this for you. The one is called RR Tools. It's by Ben Marwick. I'm sure you must have read some of his stuff for this week. How Computers Broke Science. All right, everyone go read that article. It was an amazing article by Ben Marwick. And he wrote this R package to basically make this. And then there's also Project Template, which is a project template. So we're not going to use them, but I just wanted you to be aware as we keep going through that you can even automate your file structure in R, which is very cool. Okay. So your first thing, I'm just going to have you make a data and results folder if you don't have one already. In your data folder, you should have our unclean data. In our results folder, you should have your clean data, the one you just downloaded. So you can do that.
You want us to do it in R?
Yes. Just click New Folder, and then just add it in.
Sorry, it was data and...
One is data and one is results. And the other good thing about R projects is it sets your working directory. Otherwise, in R, you'd have to do that manually. Okay. All right, so has everyone made those folders? Just one called data, one called results. Your raw data, the data that is ugly, or unclean rather, sorry, should be in the data folder, and the data you just downloaded that is clean should be in the results folder. That's important moving forward. Okay. All right, so let's get into it. So this is also from Ben Marwick. I stole his thing. So this is basically his idea of reproducible report writing. So the idea is you have one R Markdown file. You have your text, your code, your citations. You use this package called knitter that basically does all this. And you can get your stuff in a few different formats. One is HTML, like this web page I made. And one is a PDF, which you can also download from this website. So the idea is you want to have all of your code well documented with narrative. You want to have all of these steps, the results, your methodology, all incorporated into any sort of reports that you write. So this is his idea of reproducible report writing. And he posits that R is the best way to do that. And so we're going to pursue that notion. Does that make sense? Broadly? It's also the idea of literate programming, which is basically the idea of interweaving code and data to tell a story, to give your narrative. Okay. So some of the benefits of R Markdown, which is what we're going to be using. Again, you can version it with Git. You can easily share them. Your figures get updated. If you don't have to make changes when you create any output documents. It just has to run. So let's do it. If you go to New, File, you click R Markdown. You can also see the R Notebook, but for us, we're going to do the R Markdown file. We're going to give it some metadata. I'm going to say Utah short course. And there's my authorship. And then I can choose if how I want to output it as a PDF, or since we talked about academics, I could choose an academic journal for which I want to submit. And then I could have their particular style. Then I don't care about that, so I will just say create. So notice the first thing, it gives you a lot of stock information, which is going to be useful for us to just get oriented to R Markdown. So does everyone at least have this? So just new file, R Markdown, give it your name. Say HTML for now. Everyone's there? Okay, great. Okay, so.
Mine only has title and output. I don't have author and date. That's weird, right?
Does anyone else have that happen? All right.
That's a notebook.
Did you click R Notebook or R Markdown?
Is the HTML notebook is the output?
HTML.
I will come back and look at you. Okay. So there are a few different steps. So you notice right off the bat, there are these 3 quotes and 3 quotes. And encased within those 3 quotes is some R code. So this is what's called a code chunk. I don't really like chunk, but it is what it is. Again, this can be anything. In this insert button, you can see all the languages you can choose from. So for instance, I keep a lot of my data in a database. So in my R Notebook, in my R Markdown files, I tend to go between SQL, Python, and R. And I tend to use R at the end for visualization. So there's lots of different ways you can configure the notebook to get what you need out of it.
I don't say English as a language.
I'm sorry? So that you just type.
Okay.
Here you go, the English part of it. There's also support for Chinese and French and some of the other Romance languages. So the Markdown part of it is the formatting. So 2 hashes and a title is heading 2. 2 asterisks is bold. So there are just a few different things. You can look up the Markdown syntax, but it's a way to format things nicely. So that's why they're called R Markdown. You get a mix of R, and you get a mix of Markdown. Does this make sense? Okay. Great. So let's start by just simply assigning an object. So R is a little bit different from other languages in that they call variables objects. So you can kind of think of them as the same thing. I'm going to be talking about them in the same way. Yes. So I'm going to skip down past all of the stock things. You can leave them in there. You can even run them if you want. If you could just click the little, if you click this little play button, it'll run the code chunk. So this is just some data that comes with R. So they give you a lot of test data. A summary basically gives you some summary statistics. So this is summary statistics about cars. So max, the quarters, mean, medians. And then you can simply plot that as they say.
You say you can do it or you want us to do it?
You can. I was just showing you how to run it mainly.
Okay.
And now if you look at the, oops. Okay. So let's assign a variable. So let's call it cool number or cool num. So So to do this in an R Markdown file, I need to insert an R chunk. So can you see there's 3 quotes, R, 3 quotes? So within that, we are writing R code. Outside of that, we are writing plain English. Okay, so let's just call something cool number. We do a little arrow, then we assign it a value. Can you see, Shay? Is that better? Okay. So if you run this, you'll now see that this object is here in our environment. So R is keeping track of variables for us, of objects for us. So is everyone able to assign a value to an object?
Now, how do you get the 100 in there?
You just type 100.
So cool number.
Less than, hyphen.
Oh.
Yeah, you have to make an arrow to assign a number, which is different from most other programming languages again. If you,
Also use equals.
it's not recommended, but it's doable. If you want to print out the variable, then you just have to call it underneath. You can see here is the output when I print the variable coolNum, the object. Okay. So then we can write some text. Hey, I think this number, 100, is really cool. I am a great researcher. Now for some more code, because the idea is we're interweaving text and code. So we'll just write a little narrative. Okay.
I think I did something wrong.
Let me look.
I think you got extra space.
That is way too dark. Okay, as long as you got it. Okay. Are other people? Okay. So we can do a lot of cool stuff with objects that we can do in other programming languages, such as math. So for instance, I'm going to insert another R. I'm going to call something other number. And the contents of other number is going to be cool. And a cool thing about RStudio is it also auto-completes stuff for you. Cool number times 2.2. And then I'll print it out. I'll hit the play button. You can see it's 220, which makes sense. So you can treat these like any variable in any programming language. You can do math with them. And then you can see it's also showing up here in our environment panel. So R is always kind of cluing us into what's happening. Was everyone able to do that? Great. Okay. So one of the main reasons people use R a lot is because of the functions. There are lots of great functions for statistics in particular, but again, we have these 10,000s of other ones. So a function usually gets something called an argument. And an argument is basically the thing inside of the parentheses. It's something you're giving to the function and say, hey, do your magic on this object. Does that make sense? Okay. So there are lots of different built-in functions to R. I'm going to use one called square root, which is SQRT. So I say, yeah, hey, what's the square root of other number? I don't know. I better insert an R chunk and find out. So square root other num. And when I run it, it tells me the square root is 14.8324. So this is one example of a math function. So here is a challenge for all of you. Type in library help base, and I'll do it with you. So in this console, library help equals, can you see it?
Do the spaces matter? Where?
Here, I am fixing the resolution on this. Okay. You should see a thing on the bottom right called console, or the bottom left, sorry. I want you to type help equals base. And what that will do is a window will pop up for information on base R, I would like you to find another function, another math function, and apply it to one of our two variables, and then tell me what you did. Here, I zoomed in. Hopefully that'll help.
Okay, help base what? Repeat that, please.
I will. Okay. It's help. I don't know what. Yeah, I'm sorry. Is that, can you see? Library equals, library parentheses help equals base in quotes. Find some math function and apply it to one of our objects. And then tell me what you did if you finished. So what should happen is this documentation should pop up. And you can search for some math functions. So I'm making you do this for two reasons. One, to get used to functions. And two, to get used to looking for help with our stuff, which is in and of itself a skill. So did you see one?
No, it's, this never worked. Don't bother with me. That's okay.
Oh, stop. So the reason it's not working is because, oops, there's no, this R chunk doesn't look like it ends. Do you see how this one is gray and this one is white?
Yeah.
So if you just copy that,
Okay.
that should work. Oh, and there it
Okay,
is.
there it is. Okay.
Yeah,
I'll do the
so it
rest of
just,
now. Yeah,
okay,
got it.
cool. So you just need to close the,
Yeah.
all right. So what is everyone doing for their function? What are you doing for your function? Yeah, that's a good one. You can think of any stats thing, mean, min. I guess min doesn't make sense. You can multiply it by 1 billion, since that didn't work last time. You're getting the data set?
Mine didn't finish downloading this morning.
Oh, okay.
And it won't download now.
Yeah. Okay. Okay. There's no online thing for this, or else I would point you to it. I'm sorry. Okay. What is everyone down here doing for their function? Did the mean? Okay.
I tried to do zap small rounding of numbers. So I made like a square root into a square other number, and then it zapped small square root, but it just put out 14.8.
Huh. Can you go back to the documentation?
Yeah. I mean, maybe I don't know what that means.
So if you try to use a function and it doesn't work, R provides a way to help you with that.
How can you find the functions within the list? There's a lot of things here.
You can think of a statistical thing you want to do. Exponents, for example. If it doesn't work, you can just, in the R console, do question mark zap small. So question mark function name, and it will tell you everything you need to know about a function. So it's a really good way to ask for help from R.
How do you do that again?
It is just question mark and then the name of the function on the R console, which is this down here. So I could do question mark mean. And on my help, the documentation for mean popped up. So I could see how to use it. And what it is. How do they calculate the mean? Okay. So is everyone able to apply a function to one of our variables? Okay.
How can you possibly do mean to only one variable?
It works, but you'll get one number.
Just do cool num, other num. Right?
Sure.
Comma between, right?
You can multiply them. All of these are named pretty transparently. Okay. Okay. So in the interest of time, I'm going to move to different data types in R. So does anyone know what a vector is? What's a vector?
It's a
Exactly. So you can have vectors that have multiple indices. You can have a vector that's just one across. So if I made 2 vectors here. One is a vector of numbers. You notice because they are numbers without quotes. And one is a vector of states. So when I enter vec1, which is the name of my vector, then you'll see that it prints out, and the same likewise. So you can take the values from one vector, put them into a completely different one. And the reason we need to know about vectors is because they'll help us when we learn about data frames, which is the way that we interact with tables in R and spreadsheets. So typically when we have a CSV file, to put it into R, you put it into a data frame. And so we need to understand vectors before we can understand data frames. Does this make sense? Okay. So for instance, I made another vector called vec, or more vec. And basically what I did is I took part of vector 1 and I gave it a list of indices. So do you know how you traverse a list in any other programming language? All right, so more broadly than that. How do you get the location of a number in a list? So, yep. Except in R, it counts from 1. So basically, you have a list of things. Here's my vec1. 1, 2, 5, 8. I'll make that a 7, 9. So this is a list. If I want to find the first thing in the list, then I have to call it by its location, and its location is 1. So one way to do that is vec, and then I pass it the number 1, which says give me the first item in the list. Does that make sense? So when I made this vector, I said my new list, I want the first item in the list in vec1, which we just made. I want the second item. I want the third. I want the second one again. I want the first again, and etc. So then when we print it out, you'll see that they're not the values 1, 2, 3, etc. They are the values of my vector. Does that make sense? I basically subsetted my list and put it into another list, and I did that by getting the location of items.
What's the C doing in that frame?
It is getting the across. Sorry, that's a terrible way to explain it. It's when you.
Finding the list of positions.
Yeah, that's a way better way to explain it.
I'm not trying to understand
Yeah.
syntax.
No, I understand. I'm trying to put it in plainer English, but okay.
I used to always say it was like equivalent to the Excel function concatenate.
Sure.
But or combine.
Yeah. So you can also subset vectors with different signs, such as greater than or less than. So for instance, I want to see all of the values in my first vector that are both less than 2 and greater than 5. So I have a list. Or if I want in vector 2, I want to see everything that is equal. So that's a test of equality. That's not assigning a variable. Everything that's Minnesota and also OH. That's what the pipe is. Does this make sense? Okay.
It is and not or.
Yeah.
The pipe is or?
Oh, sorry. I thought you said or. The pipe is or. Okay. So I would like all of you to make a vector. I will go back up to where I did it the first time. These are my first 2 vectors. So make a vector of like 5 items. Doesn't matter what the data type is. Could be numbers, could be characters.
Can it be a mix?
Sure. I'm pretty sure.
Character should be in quotes.
Yes. If you put numbers in quotes, they'll be counted as characters. And then once you have created a vector, I want you to try to subset it using some of those functions. So I'll scroll back up to where we create a vector.
The vector inside an R function.
I'm sorry?
Yeah. It's not in text, it's in an R function, right?
Yep, this is, so everything with the gray, it's a gray background. I'll do it in R, okay. Let me make this bigger. Okay, here's how I made a vector the first time. So I want you to just make one vector of 5 items of any data type. And then I would like you to make a subset of those vectors. And I'll walk around if anyone needs help. Okay. Doing okay? It's this old hat. I'm sorry. It's a beginner for you.
Make a vector, then make a subset.
Then make a subset of a vector. Okay, you good?
What's a subset?
You basically take part of the vector and put it into a different vector.
Oh, okay.
Yeah. Okay. You guys over? Okay. Okay. To subset? So is everyone good if I scroll down on creating a vector? Okay. This is one way to subset a vector. So you're just asking for different stuff from the first vector. You can also do it by using operators or by asking for equal text. So you can subset in a few different ways. Here, you can sort of see those on the same screen. Okay, has everyone successfully made a vector? It shouldn't do anything, but you should see the vector pop up in this environment tab. So where your variables are, you should see a vector as well. Yep, there are your vectors. You have one. Did you subset it?
Yeah.
Okay, that's a subset. Oh, yeah. Very good. Were you able to, looks like you made a vector. You made 3.
Mine isn't, when I do it, it wasn't.
So you can't hit enter, and it's not in an R chunk. So it has to be in an R chunk. Okay. You good?
Yeah, okay, sorry.
No, no.
Not good, it's not coming up.
Okay, let me see.
It's an R chunk.
So you need to create the vector, you need the C. So you this should be, the list should be in parentheses.
That?
That should be the opening and then the end, the closing. Then right before the first parenthesis, put a C. And then hit run.
That's what
The
I'm
little
saying,
play.
hit run it with, okay, now
Yeah,
it's working.
there you go. Just missed the C. Okay.
Syntax.
Yeah, always syntax. Huh? You need a C before the parentheses.
Oh,
So don't forget the C before the parentheses when you make a vector, or it's not going to work. Okay, so were you able to get it working? Okay. All right. Let me scroll up and just run this real quick. So you should be able to see in your global tab, do you see my vectors? Oops. You should be able to see your vectors. Okay. So R was made for data analysis, so there's a good chance that it's going to have to deal with the messiness of data as we explored earlier. So one thing that we pulled apart is that some things have missing values. So what does R do when something has a missing value? Let's see. Oh, oops. So when I did mean of cat toys and max, I got NA and NA. And that is out of order. You can also do math on vectors. Sorry. So when I did the mean and the max, I got not NA because of this. So that's obviously not good, right? I want to do my statistical tests. So there's a neat little thing you can do to tell R to ignore null values, ignore the NAs, and it's the NA.RM equals true. So when I do this, I get the actual mean and max.
What is NA.RM? Like,
That basically tells R to ignore the null values, or to ignore the NA.
okay.
Oh yeah, sorry, RM is removed. Does that make sense? Okay. So that's just a good little trick.
So .RM will work with anything you want to yank out of a list or something like that?
I think it only works with the nulls. Unless you do some fancy stuff, in which case I think you can. I don't even my R users. Have you ever seen it used with things that aren't nulls?
No, because it's a
It's base.
argument for the function, so
Yeah.
it's pretty specific. Like in this case, the main function. So
So you can't necessarily logic it out of Unix is what I was getting at.
not in this exact way. You can use like Unix commands in R, but it's not.
Insert bash.
You can do that. There's like, you could grab.
Usually, you can just do a filter command. You can subset it by and just say I don't want the anything with an NA value. Throw it out of my data set.
I'm not a programmer, so.
Not that I remember all those. Yeah, but okay.
No, I'm trying, but it's okay. I want to watch it. I want to learn more.
Yeah, like if you were doing it large scale with a complicated argument, you can use like a graph. Or take a regular expression, for example.
Okay, so my challenge now that you know how to make vectors and subset and use functions, I want you to create this vector. And I want you to use R to tell me how many people are taller than 67 inches. And then I want you to tell me the median height of folks in this list. Sorry. sorry. I'm trying to see why my book isn't building. I'm sorry. I don't. This book keeps failing me. Okay, so let me know when you have done this. I believe in you. This is going to be good. We might have to skip a few things, but you will at least be able to create data in R. Okay. Can I scroll down from this? Okay. So just number of people taller than 67 and median. That's all I want. Okay. Oh, data frames are next. did you build? Okay. Okay, has anyone got the answer for me?
I think I do.
Okay.
Should I?
Yes, tell me. And then we'll see if people are verifying. And the median?
Oh,
64?
64. Okay. Is this what other people got? Who's gotten it so far? Number of people taller than 67 inches and the median?
It's the fact that the NAs were taller than 67 inches for me.
Sorry?
I was like,
No, don't count. Use R. Come on. We just did this.
no, I know, sorry. So I had to print out like all the people who were above 67 inches, and it said the NAs are in that for me. I don't know. So I did heights over 67, and
Yeah, because there's no
said NA is
there's
taller
no
than
NA
67.
equals true. You didn't remove it.
But I
You removed it from the median.
Oh, so it's also an argument for.
You can give it a go,
Okay.
but
Because this isn't a function the way median is it?
yeah,
This is this little thing.
believe so.
Okay.
Put the name of your vector inside that vector here. Commands are within the parentheses.
Okay. Did anybody else get an answer for this? We confirm or deny?
No, you can't do NARM equals true on the
Okay.
greater than.
So if
It says.
so like n, there's my vector.
for the greater than,
Yeah.
it returns a vector,
X
Yeah.
is
and
greater than
if
67.
if
I don't
it
write
returns a
because
vector
the
of the same
things
length
are-
as your input
so,
vector
okay.
that you're comparing.
Um,
Because one of the reasons why R is good is because when you do a command on a vector like add 5 or greater than 67, it compares it to every single element in the vector individually.
Yeah.
So you don't need to loop through it like you would in other programming languages. So if you just do the vector greater than 67,
Like if I have my-
it'll return a vector of true false, where true is greater than 67, and if the object in the vector that it's comparing is NA, it'll return NA then. of the
Okay.
vector. So you can remove NA after you do the comparison.
Or,
So then after I entered that, I do
height
RM.
60. Okay, no, that's not
So
what
what
it's
can I
saying.
use to weed out the
I just never count anything.
stuff above 65, whatever the top was? Just greater than it?
What do you want to do?
Like
When you
watch
say,
things,
oh,
Yeah, so the,
Oh,
you
if
get
I want to know
vector,
basically I want to know
and
the length of the vector,
then,
that's why.
because
Count
this is
is
R.
the length of height.
Hold on. So the vector,
And I have
so
to
this
install
is,
it.
this is the vector.
So it's
Yeah,
my length
and
3,
then
so that's my
This
count.
sum is a function.
Within base R, it's not the.
The
So what were you
sum
trying to do?
function
I'm trying to figure
takes
out
two inputs.
within this vector
A
string
vector,
how many
and then
values
whether or not
are
you want
greater
to
than
use
Okay.
NA.
67.
Guys motored.
And so this is actually another vector.
I'm watching.
You got a lot done.
No, I
Look
don't,
at
but I
it.
didn't get the stuff to work because I don't know what.
Here, ready?
I've got the strings and stuff. That's okay. You don't have to.
Just do
I
heights.
didn't come here really to learn the program. I came here to sort of hear the concepts.
So I would be
Heights
like
greater
filtering.
than 67. So this
height.
returns
So you opened with this one and you close with this one.
height.
With
Right?
the, well, I don't have
Yeah.
a
It
name for this
doesn't matter.
vector.
That's what I'm doing.
I don't
Part of
think
these
that
I'm doing.
You can just do insert. It's just the easiest way to do it. So then you're guaranteed not to mess it up.
That is actually one thing with R, is that you've got all this stuff that's in base R, which is, to me, hardcore programming. And then there's all
Oh,
these
come
things
on.
that-
Base R is hardcore.
Well, I mean, it's more, well.
It's one line for a lot of
But
stuff.
you have to like worry about indexing and everything like that.
Yeah.
Once you get into the tidyverse, you never have to worry about indexing ever.
Okay. So that
Yeah. And
Should
then
work.
the sum just
So
adds
you
up
only
the
have
value
the R in brackets after the first
vector
quotes.
after
Okay.
That's it.
And it's, this is open and then this one is closed.
I believe.
This one is closed, yeah, okay.
Okay. Can anyone else confirm or deny this before we move on to data frames?
Maybe I just typed in
6 people taller than 67. The median is 64. Is that what everybody got?
I have no idea how to do it.
Okay.
We got 5 people taller than
Yes.
67.
You got 5 people taller?
Yeah, I may have entered
I got 6.
I got 6.
You got 6?
6 and 64.
6 and 64. So there.
I reproduced his results.
All right. This is the
On
point.
my own.
Okay. So all of the functions are called kind of what they're called in stats: mean, max, median. So you can just pass the vector to median.
So, but how do you identify one as they're taller than 67? What's the command for that?
You can't do, oh, actually, you had a really good explanation for that. Do you want to explain how you get the values greater than 67? How you count the values greater than 67?
Oh, you just use sum. That? Or
Now, how did you determine how many people were taller than 67?
Okay. So, because R stores all of its, because R's main data storage thing, I don't know the
That's fine.
term, is a vector. When you do a mathematical operation to the vector, it does that operation to every object in the vector. So if you have like a vector of 10 ones and then you add 5, you just do that vector plus 5, you'll get a vector of 10 sixes.
Right.
So it applies the operation to each object in the vector. So you just do greater than 67, and then you get another vector that's true or false, or NA, depending on what the comparison is for each object in that vector.
Did anyone else do it a different way?
So what's the actual code line? Like,
It would just be the name of your vector
okay.
greater than 67.
Yep.
Oh, okay. You don't have to.
So you
put it
can
on
see
the
I
count
did this for, we did this to see what values were less than 2 in vector and greater than 5, which returned a subset of the list. It's like straight up math. It's greater than and less than. It's mean and quotes in
Once you start working in data
yeah.
frames, it's like
yeah.
Well, what's weird is I did what you
Like
did
here.
a lot.
I,
Yeah.
I converted this to a data frame, so now it's like a table.
You got 7L? I have no idea. I'm gonna have to come look at what you did.
They're basically in a table.
Is that
So now
length?
there's a filter on the table
Yeah, I
for
think
everything
so.
greater than 63.
Because
It's supposed to be back like
I
that.
ran it.
Okay.
You know, so
Yeah, you're summing.
Okay. For the sake of time, I'm gonna move to data frames, which are arguably more important than vectors, although they're built on vectors. So a data frame can be created by hand. It's most commonly generated by the read CSV file. You can also read from databases into data frames. So a data frame is basically a table where the columns are all vectors that have the same length. So all the columns have to have a single data type. So you can see in this fake data frame, the first column is all numbers, the second are all characters, and the third are all Booleans, which is just true or false. So this is why we need to know vectors, because we can then later put them into data frames. Okay, so let's use our own data now. So you all should have the clean data set in your results folder. So one thing that breaks on a lot of different people's stuff is this thing called hard-coded paths. Does anyone understand what a hard-coded path is? It's like my whole home, Vicky, downloads, et cetera, et cetera. So if I was to send this to you, it would break because you're not home, Vicky, downloads, 2018 Utah. So we need to use something called relative paths, which is essential for reproducibility. Just lets you send something to somebody else with the same file structure, and they can rerun it. Does that make sense? So they don't have your name in the file path. So there's actually an R function that lets us do that. It's a library called here. So it's just literally, to call it, it's just library here. So we can do that in an R chunk, and in our markdown chunk. So if I do this, library here, oops, in quotes, and I run it, tells me here starts at this. So it sets all the paths relative to my big project directory.
Says there's no package called here.
Should I install packages here?
You can. If you don't want to, it would probably take 2 seconds. If you don't have it, it's just in your R chunk, install .packages here.
Okay.
And so then it will tell you everything that you write from here on out is going to be relative to this path. So this is really useful. Install .packages here in quotes. So if you all download my our project file for this book, you'll be able to see it. But for your own local installations, it's just that. Should take 30 seconds because it's not a big package. Okay. So now we have all this clean data. So we did all our data cleaning in Open Refine. So now let us put it into our project. So before using this, I would have to hard code the path to my data. So now I can just say, go to the results. So when I send the script to somebody else, they'll just have the results. Does this make sense? So basically, instead of hard coding my path, I can now send this file to somebody, and they can just get up and going without being stopped. So we are going to put the CSV that we made into a data frame. So we're going to insert a chunk. We're going to call it uni. And it's just read.csv. And then we have to give it the path to the file in quotations. And ours is results/2018. See you tomorrow. It's okay. So now when you run this, you should be able to see now that I have something called data. It is called a data frame that is called uni that has 75,000 rows, which is in line with what we did in Open Refine. So has everyone read in the CSV?
No.
Okay, I will give you a minute. Okay.
Is there a way to cut and paste the results piece in there?
If you go to your file browser and back-click on the file, and you go to Properties, you should see the file path. Although if you used here, you shouldn't have to hard code, which is just the chunk before. Okay.
So now I have the results.
I put my data like.
Oh, data's for raw.
Oh right.
Do
Can you run that?
Yep, so if you run that, if you just click the little play button, you should see this pop up in your global environment, in your environment pane. And we can actually click, see it has a play button. You can look down to see what all the data types are. And if you click it, you can see you can open the data frame right in Open Refine, so you can visually see it as well. So has everyone read in the CSV?
Oh, finally.
Yay.
I didn't write .csv.
Okay. Make sure you have the file path. Okay. Wow, our clean data. I'm just going to add a narrative as we keep going. Okay. So we have read in our table. Now let's just double check that it looks right. So we can do that with head uni. The head will just return the first 6 rows. We could also do tail, which returns the last 6 rows. And so when we do that in RStudio, you should see these 2 little boxes. You can flip between them. The first one is heads, and the last one is tails. Was everyone just able to do head uni, tail uni? Just to check the data to make sure it looks good. Okay. Looks so good. Okay. So now that we have stuff, we can do more with it. For instance, if we just wanted to see the first, we could do uni 1, which just gives us back the first column, which is just the list of universities. So you can go more in depth if you want to see different assortments of rows and columns. That is something that you are able to do. Okay. So there are lots of different good functions for data frames. So one is like n row, which returns the number of rows. N column returns the number of columns. We just saw heads and tails. Names returns all the column names. And summary gives us summary statistics for each column. So this is pretty useful depending on the data you have. And we can also subset the data by putting them into vectors, which we saw before. So for instance, if I was to run this R chunk, oops, and I say unis is, and then I did uni, and in square brackets passed it the name of a column, then I will just have created a new vector that is just has the list of lists of universities. You can see that there. Or a new data frame, rather, that just has the list of universities. So you can subset data frames in a lot of the same ways that you can subset vectors. Does that make sense? Okay. So your challenge, take uni, which is our data frame, make a subset called uni underscore money that contains just the columns for the university names and the endowments. All right, let me come back and see what's going on.
It's already syntax. It didn't read it in. It didn't like my syntax, so I'm stuck.
Read CSV. Are you sure it's in results? Can you go up one level?
Yeah, I'm in results.
Okay.
I'll go up.
Can you?
Results.
Okay. Oh, capital R. This looks like lowercase r. You have capital R.
Unix, that would do it.
Yep. So just hit the play button again.
It's got 2 quotes. I don't know why it's got 2
Oh
quotes.
yeah, just delete one.
Yeah, well, hate this keyboard.
All right, so that looks like it worked. Here's uni.
Okay, so now I need to go back up and.
So now you can subset it, and I'll scroll up. Yeah. So when you have successfully created this subset, let me know. Okay. And to create a subset, you can either pass the names of the columns or the locations of the columns. So 1 and 2, or 1 and 5, for instance. Does that make sense? To subset it, this is making a new data frame with a subset.
I think how you would put that in there.
What do you mean?
Sorry, so uni 1 I understand, but uni 1, comma 5, wouldn't that be a row and a column?
Mm-hmm.
So uni combine uni square brackets 1, comma uni square brackets 5, and then you have to put that in a data frame? Or you can just tell
Sort
me
of.
instead of me guessing?
No, you guessing is good. Yes, it would look something like that. You could also just add vectors one at a time.
Okay, scroll back down.
So it was like very clear to me how to do it with the names.
Mm-hmm.
Like that, and then I checked it with head.
Yeah.
But with position, I feel like I just got lost trying to think how would I do it with position.
So, sorry, I forget the macros on this thing.
I'm like, do you have to have a comma and then leave it empty or something?
Is this gonna work? Oops. Yeah, that didn't work. this is something I have to look up.
I mean,
You can do it positionally, but
It just got so
Sorry.
confusing in my head.
Can you scroll back to the calendar then?
yep. You just make a subset, so you have the university name and the endowment.
So where can we visualize what the table looks or what the
You can click the plus sign next to in the data. Do you see the the play sign here? If you click that, you can see. Okay. It should pop up in a window like this. And if that doesn't work, just try clicking the name and not the arrow. Okay, has anyone made a subset? Were you able to make a subset?
No. So I'm putting it in here.
Okay.
And it's coming up with the dollar
That looks
signs.
right.
But I thought we stripped all these dollar signs.
It's a different data set. I didn't do it because I didn't take the time to do it.
Okay.
So that looks right. You did it. Yeah,
No,
good
this-
job. That's it. I just wanted the university and the endowments.
No, this is the raw data I pulled in.
Oh, so just stash that in a variable. Stash that in a data frame. If you scroll up, where did you subset it?
I didn't.
Huh, what? Can you scroll down? Oh, can you hit that arrow? Okay, there it is. So now you can just take the university and endowment columns and put those into a data frame. So you do that with just name the data frame uni_money in an R chunk. Yeah, and then make the arrow. Sharp completely lost. Yeah. So now you say uni, square brackets,
And then
in quotes, universities, the column names, and comma, endowment. Yeah, and if that doesn't work, yeah, no plural, and hit run.
how do I know if it worked?
Click uni money. Or sorry, can you just do uni money? Just type it out on the next line,
Mm-hmm.
and then hit run. Ruh-roh. Do you need the C? Yes, you need the C. It's this with a. All right, so I'll show you a different solution. There's actually a function called subset. So I just selected the subset. So in what's called base R, just R on its own without any fancy packages, there are lots of these different things for dealing with data frames. And subset is one that I find really useful. And this is how I created a subset. You can also do it this way as well, or you can use the function as you want. So there are multiple ways of achieving this, using the function or not using the function. So I made you do it the not using the function way, but here is the function way as well. Okay. So, sorry. So I can show you how to deduplicate the data. And then tomorrow I can try and fit in some time for this. Tomorrow we're doing Jupyter Notebooks, which should probably take like an hour. And, oh my God. And repros and viz trails, which will not take so we can pick up the rest of this tomorrow as well. Would you rather I save deduplicating for tomorrow? Is everyone in total cognitive overload? Okay, so why don't we end here? So we ended at subsetting, And we'll pick up the tail end of the R lesson tomorrow. Then we'll do Jupyter Notebooks. And then if we have time, we'll do repros up in Viz Trails. Does that make sense? Is that okay with everybody? You guys all did a really great job. Don't feel like bad about anything. Programming's really hard and weird, and R has a weird learning curve as well if you've never done anything like this before. So the fact that even you could put something into a vector or a data frame, or even understand a lot of these concepts, or even think about what you could possibly do with a lot of these things is a step in the right direction. So thanks for bearing with me today. Thanks for your great attention and work. I really appreciate it. And be free. We'll pick this up tomorrow.